I forgot to remind you, sorry.
All right, guys, thanks for reminding to start recording. So today's topics would be, first hour, we do measuring distances and detecting intruders. And on the second hour, we're going to be using infrared remote controls. And we're going to be building all kind of cool logics to that. And both of them are fascinating and opening a lot of opportunities to design smart projects with them. For measuring distances, we'll be using a device called ultrasonic sensor. This is cool, looking like a robotic eyeballs. And in reality, those are the transmitter and emitter of ultrasound. And we're going to be using it to transmit the wave, just like bats or dolphins do. And then we're going to detect the reflection of that wave. So a little bit of a kind of an overview and a history, how it works, and some math behind it. This device has two ports. One emits the signal, and that's initiated by putting some electricity onto the trigger input. I will explain it in more details. And that signal consists of several short pulses. And then it goes into a delay mode, and it starts listening. It listens for the same sequence of pulses coming back. And we assume that the speed of sound is 340 meters per second. That can fluctuate based on temperature, humidity of the air, but it is around 340 meters per second, or 0.034 centimeters per millisecond. And of course, you can, knowing the speed of sound and the time it took from the moment that you emitted the wave to the moment you received back the reflected wave, you have the time, so you can figure out by dividing the distance to the speed of sound, you can figure out your delay. So if you know the delay, then you can figure out the distance. So it's the same way as a triangle of Ohm's law. A little simple formula. We don't expect you to memorize it, just need to know the fundamentals. So the principle that this sensor works on, it works on emitting the wave, waiting for the reflection to come back, and then figuring out from the delay how far that object is. Okay, so you can use it, for example, as a parking assist in a garage. You can move your car without even watching, just by listening to the beeps. And as soon as you get close to the wall, you stop your car because you know, okay, you get warning that you have reached the optimum position. Second application is detecting anything that is not supposed to be there. That's what I said. If you want to detect intruders in your room, you put sonic sensor in it, and then somebody enters the room, you start getting disturbances on your sensor, so you can build logic. Oh, if something is in range of 2 meters, sound an alarm. Okay, and we can do that with all the parts that are in this Arduino kit.
You have to unpause me to get me.
So let's go to the Tinkercad, and I will show you how to connect the sensor. And we are going to actually build it.
We do our homework thing first.
You want to look through the homework?
Yeah.
Okay.
Yeah,
well, I didn't do it. I was giving you as a challenge.
No, let's do the presentations. Absolutely. Yeah.
Oh, okay. You wanted to show. Excellent. Okay. Let me stop sharing, and please go ahead and share your code and show us the video if you have it done.
So I'll just turn on my camera because it's all set up.
Yeah, just point it directly to Arduino.
Yeah. It won't let me. There. There. Oh, stop it.
Nice. Yeah, that's exactly what we asked for, right? Oh, and you put it in a circle. That's so creative. Good job, buddy.
Wow, it runs. Yeah. Do you have a couple of LEDs in each row?
Yeah.
Wow. Okay.
Nice, good job.
Guys, I recommend you to look
That's
into
great.
the into getting the on Amazon. There, the people sell the individually addressable LED strips. For this class, we didn't do it. We do it for like a full seasonal Arduino class, but they're cheap. They're like $13 for 50 LED strip, and you can build projects similar to this, except you get 10 times more LEDs. And there's all the all multicolored, so you can tell them the intensity, brightness, the color, and how fast to illuminate. And there are so many libraries and projects available for it, and you can innovate and create really cool effects. So I'll share the link in the chat. But this is amazing. I like your algorithm.
Good job, Will. Anyone else wants to show
Can I
their?
mine?
Yeah, go ahead.
And it turns off faster and faster.
Oh, you did actually what Alex asked.
Yeah.
And then it restarts.
Wow, look at it go. That's awesome.
Good, good.
And you used almost every input on the Arduino. How many you have? Like 12?
11.
11. Good job.
Good job, Ricardo. Good job. Nice. I'm very proud of you guys. Yeah. Anyone else wants to show?
No, you're good? Okie doke. So let me then go back to my share screen.
Good job. Thank you so much for sharing.
So the here's the quick circuit of the ultrasonic sensor and Arduino. I don't put any other elements in there, but if you want to make a logic and you can say, let's build an alarm type algorithm that's gonna, like, for example, buzz the sound or illuminate the light. If there's an object detected and it's closer than a certain distance, you're welcome to throw in another LED in here and connect it to any of the digital ports. You can even use your existing function that you have. Just delete this. The one that is currently running. So if you remember how we did it last class, we have this function, right? Running light. So today we're going to be adding more tabs to our program. So let's just stick to the exact same code that we have in our main project. And we will be adding measure distance function, and we will be adding infrared control function. And if you'd like, you don't have to disassemble your running light, keep it up, but we need to free up maybe a couple more digital pins for ultrasonic sensor, because that's what we need. If you used up all the pins on Arduino, you may need to disconnect like 2 LEDs and free up space for ultrasonic, and then for the second hour when we'll be doing infrared, we're going to be using those two. Okay, so I'm going to move this to the side for now, and I'll show you that this is the sonic sensor. I will actually want to bring up the different picture. Ultrasonic sensor Arduino.
This is how it looks in your set, guys. Okay. It's a big one, hard to miss.
So this is the how it looks in your kit. It looks exactly like this, and it's quite big, so you shouldn't have any trouble finding it. It has 4 pins on it. So 2 pins are power, so you need to connect to ground and plus 5 volts, the same way as we were plugging all of our circuits before. But this one is not analog. This is digital sensor. It has its own clock, and it has some other elements on the back. So this sensor actually sends encoded digital signal to Arduino. It doesn't send a variable voltage like photoresistor, for example, that we were using, or like a potentiometer. It sends pre-programmed sequences of pulses that Arduino knows how to decode. And also has 2 other pins, trig and echo. So who can tell me what it sounds like? What do you think trig and echo are for?
Triggers to start it and echoes to receive.
I think echo is for it to like repeat it.
Yeah, I mean, that's correct. Trig is short for trigger. So when you pull a trigger, it creates a sound. And then echo is actually the pin for detecting the reflected wave. Grant is asking, is it going to be loud? No, maybe for some animals, but not for us because we cannot hear ultrasonic spectrum. So maybe you have a pet dolphin in the house or a little bat. That might drive it crazy because it might listen to it. I don't know how pets actually, I have a dog, maybe my dog will hear it. But I never hear the ultrasonic sensor in operation. It's beyond my audible spectrum. Okay, so if you notice, the Tinkercad has weird sensor in its parts with only 3 pins, but don't pay attention to it because they programming it to be trigger and echo in 1 pin. The blocks, though, if you look at the blocks, there is the thing that's inside the input category that says read ultrasonic distance sensor on trigger. So if I pull it up, it has 2 variables connected to it. It says read ultrasonic distance sensor on trigger pin. So for example, if we connect trigger pin to pin 10 of Arduino, and if you have a sensor with 3 pins only, you can keep this, so echo pin would be the same as the trigger. But if you have one of our type that we have in our boxes with a separate echo and trigger, then you're gonna have to decide which pin you have free on our Arduino to connect to the echo pin. So I select, for example, 10 for trigger and 11 for echo. And that's all you need. So if you throw this thing in your Tinkercad, so for example, here in my schematic here, what I do, let me delete everything. I'll delete all that thing here.
Alex, does it matter which way you put it? Like, because there's like no room when you put it in.
Well, the recommendation is not to have anything in front of it. So if you, for example, have a bunch of wires on your breadboard, try to put it on the edge of the breadboard so that it faces outside. So for my case, for example, I would probably like spin it this way and plug it somewhere on the edge so that it is facing that direction that doesn't have any obstructions. Because we want to actually test it, and we would like to put some obstacles in front of it and see if it reads these values.
So you're supposed to put it facing away from the wires that you have there?
Yes, exactly. So you need to pay, first of all the legs supposed to be in each individual row. So you cannot plug it in like this. Because if you plug it in like this, you create a short circuit between all 4 legs. And you cannot use it this way. You can't put power to it, you cannot read signals, you cannot call triggers, because all the legs are shorted together. So you have to put it either this way, facing towards Arduino, or you spin it the other way and you face it. So whichever way on your actual breadboard is, you get clear shot between the sensor and the room, face it that way. Okay, and then we will be connecting legs to appropriate pins. So once you figure out what is your correct position, you plug it into your breadboard, and then you start reading one by one the designations on the pins. So if it's a G and D, that leg is supposed to be connected to the negative plus on the breadboard. So if you see my breadboard has plus and minus, you should know that by now because we were using it for 3 days already. So the ground leg connects to negative. The plus 5 volts, in your sensor, the location might be different. For example, on my sensor, plus 5 volt says VCC. So that VCC leg, this one, supposed to be connected to plus 5 volt on the breadboard. So it goes to this one, to plus 5. And the trigger and echo, both of them go to their individual pins. Let's just agree right now to use, which ones did I use? Which guys you have free? Do you guys have 11 and 12 available?
I've got 10 available.
Yeah, so let's agree that we're gonna use 11 for trigger and 12 for echo.
Okay.
So
Okay.
am I supposed to put the green wire that you have there on the 5 volt thing, or am I supposed to put it on trigger or echo?
Both of them. So you need to connect ground to negative, the VCC to +5 volts, and then you're gonna stack with 2 more leads coming out of it, echo and trigger. So we're gonna go trigger 11 and echo 12. Unfortunately, this guy ultrasonic sensor is not allowing me to change the number of pins in here, so I cannot really prototype to the same way as we do with the 4-legged ones. It just has 3-legged.
Make it look like it. Like, add another wire in there, okay?
Yeah.
Maybe.
So I'll add another wire. It's gonna be 11.
Make the blue. Make the blue one ground and the green one. Make
So
the blue one.
I'm gonna make the blue one for trigger, and I'm gonna make like purple for echo. So now we are gonna assume that our sensor has 4 pins, just like our actual sensor does. So get that assembled, and if you'd like to make a responsive, so for very basic code, what we're gonna do is we're just gonna throw out the actual measurement in centimeters to the serial monitor. But if you would like to make a logic, so if the distance goes beyond certain value, we're gonna light up an LED, then you can throw an LED in there as well. If you already have your string, don't do anything, leave it there. We might activate it. That would be awesome. So I'm going to plug my LED in here. Have a resistor. And I'm going to connect this guy to some output. Doesn't matter which one. You probably have all of them from 2 to 10 taken already by your strings.
My board's empty. It's okay.
Yeah.
I emptied mine.
So it's not principle. For example, if you have all the pins already taken and you have like pin 2 and 3 available, use those for echo and trigger. I'll show you in the code where we change those designations. It doesn't matter. We can use any digital pin.
I have a question.
Yes, Catherine.
Do you need to like disassemble the project from yesterday?
You don't have to. You don't have to if you have available pins still on your Arduino. So if you have any digital pins available, you can use them.
Can you disassemble it if you want to?
If you want to disassemble, you are free. Yes, you can disassemble. There will be no homework assigned to that anymore.
Good.
Yeah, if you're done with your running lights exercise and you don't want it anymore, you can disconnect everything, put it back in the bag, put it back in the box.
Can you repeat the pins again? Which one goes to echo? Which one goes to trigger?
Well, we agreed that the trigger would be 12 and echo would be 11.
Okay, I'll put that in the chat box.
Doesn't have to be. Doesn't have to be. I would like to keep it open and free for everybody to select their own echo and trigger, because when I put the code up,
But in your code, yeah.
Inside the code, yes, you will be able to just select whatever one you used.
Yeah, but in your code, you'll be putting the trigger to pin 10, you said? Sorry, 11?
Yes, I will do that.
Okay, and echo to pin 12, right? There you go. That's in Alex's code.
Guys, don't draw on my schematic. Don't focus on schematic too much, because you're going to get really confused if you follow that exact sequence of wires. Your wires have positioned differently. your wires look like this, right? So you have the ground on the right, power on the left, trigger in the middle left, echo in the middle right. If you're gonna look at the Tinkercad, you're gonna try to repeat that kind of wiring, and it's not gonna work for you. Okay. So just use your head and use your logic. VCC goes to +5 volts, ground goes to ground or negative, trigger goes to pin 12, echo goes to pin 11.
Then
where does VCC go?
+5 volts. It's a power.
Oh, okay.
Hey, no. Geeks. Granty, are you suspended off the ceiling? Tomorrow I'll do the same. I'll
Alex,
prepare some mounts.
can you show the diagram?
The diagram? Ricardo, if you'll need help, let me know. If you'll need help, let me know.
A lo mejor como me vieron venir, a lo mejor creen que...
no, I'm just showing my dad something.
Ah, okay, okay.
Showing my dad.
Yeah, if you guys stuck, just make sure to let us know, okay? And Alex, you can probably like use your digital pen to draw that missing trigger echo thing.
No, then I have to reassign all the pins too, because pins are in the wrong sequence. G and D is there on top, but in our sensor, we have power on top. We have +5 volts here. Guys, what are you building there on the pin 7 now?
Again, this is...
Who is that mischievous person?
Who is it?
I think it's Catherine. No, Catherine is against her beliefs. It must be Ricardo.
Ricardo?
I don't even have Tinkercad open.
Okay, then it's not Ricardo.
Then who is it?
That must be...
Neither do I, so it's not me.
That must be Will or Ellen.
No, it's Will.
It's Will.
Hell, what you doing?
Will, why are you adding more LEDs to my schematic?
I don't know.
Okay, you know that you're gonna have to program it now for everybody.
Go well, come on.
Okay, fine.
Get programming.
It's not signing out of Tinkercad, so I need the email and password again.
Okay, you guys ready for the code? Are you done building?
Yep.
Someone just asked for the login information for Tinkercad. Can we share that in the chat again?
Tim, can you throw in the Genotech?
Cool.
In one of the classes, previous season, we used the ultrasonic sensor to create automatic candy dispenser for dispensing M&Ms. So we laser cut it.
I remember that.
You remember?
I was in the 3D parenting class and we saw it.
Yep, yeah. So when you bring your hand close to the dispenser, it rotates once and it takes out of the bunker some candy and puts it up in your hand. In current atmosphere, you can probably make sanitizer dispensing apparatus with it.
So guys, if you've
ever... or an automatic soap dispenser.
Okay, bye.
So guys, if you can you hear me?
Yeah.
Yeah. Okay. Awesome. Sorry, my mic was doing weird things. Yeah, if you've ever used like one of those like sinks where you don't actually have to touch it, you just put your hands there, or like one of those paper towel dispensers or anything, they're all made using ultrasonic sensors, right? So they're just detecting to see if someone puts their hand under them or if something gets close enough to them to register like a hand for long enough, and then they'll just go ahead and start dispensing whatever they're trying to do. So that's like one application of ultrasonic sensors. A lot of other times they're doing it for other applications, right? So for instance, if you want to have like a security system where you're detecting people walking by, or any situation in which you want to detect motion and like proximity to things. All right, so there's a lot of really cool things that you can do with it.
So if you guys prefer Tinkercadding, I'm going to paste the code in the same sketch that I'm using. So I'm just going to go to the text here. And if there's anything, I'll delete it. And I'm going to put the Sonic code in there. So as we agreed, I'm going to change the trigger pin to 12 and echo pin to 11. Then I have to modify my circuit. So trigger is yellow.
I'm sorry, but which pin on the ultrasonic sensor goes on which place on the board?
It's written right now on a screen.
Oh.
Alex, isn't it the other way around?
You can make it other way around.
Because if you look in chat,
Yeah,
we were told the other way around.
Okay,
so
let's do other way around. Trigger pin is 11 if it makes you happy. Here it is.
Yep, that's what we agreed to.
And 12 would be your echo. There you go.
If you guys connected to different pin, just make sure you put the right pin here, right?
And if you guys see inside that code, there's some math that we have discussed in our presentation and our review. Distance equals duration multiplied by 0.034 divided by 2, because distance is the wave actually have to travel twice the distance. Do you remember the this picture? So if this is a 10 centimeters, the wave actually have to travel 20 centimeters. It comes from the sensor, it goes all the way to the obstacle and then being reflected back. So in order to get the distance, you need to take the time and multiply it by speed of sound and divide it by 2. And that's exact math that is in our program here. So we take duration, which is time, multiplied by speed of sound, divided by 2. And that's going to give us distance, and then we can just print it out in our serial monitor. So you can...
Can you put the code in the chat?
I can put the code in the chat too, yeah. Okay.
Code in the chat, code in the chat.
12. I'm going to put it like that. Make sure, guys, when you copy it from the chat window, run the auto format on it so that it's properly looking. So anything between the dash lines, take it dash lines, copy it, and make sure to replace whatever is in your window. If you want to use your existing project, you can do that too. You're going to have to create a new tab and put this code in there. But at the moment, I suggest to start a new project because it has its own setup function and it has its own loop function.
Stay together.
I'll show you how we modify it after we're done with the first initial trial. I show you how to make a custom function out of it and put it in your bundle project that we already have. So right now, you use it in a new project. Go File, New, paste all the code in it, save it, call it Sonic. And I will try to actually connect mine and load it and see if it works, because I have no idea if it will. What do we do when we connect Arduino? First thing first, go to Tools, make sure the port is correctly selected to avoid errors. And then if the port is correctly selected, then you are free to download it. Mine is compiling, uploading, no errors. Done uploading, no errors, excellent. And then all I need to do now to see if it works is to launch the serial monitor. And here is my distance. I got this thing pointing on the wall on the other side of my room, so I'm showing 2 meters. And if I put my phone as an obstacle, it shows like 15 centimeters. And I'm moving it closer, and I get 10, 9, 11, 8, 7, 6. So you see, it's reading like 10 times per second, the distance. All right, works.
I haven't gotten mine done yet.
That's fine. Keep building. We have plenty of time. There's still 15 minutes before the break, and we're gonna have 5-minute break at 11. And second hour, we're gonna be making some logic connected to it, and then we're gonna cover the infrared sensors.
To make sure on this everyone's done this correctly, I suggest we actually, Emily, let's go through one and team. Let's go through everyone, ask them to share their screen and serial monitor.
Real
so
values?
We want to see, we want to see that their value is changing when they're bringing their hand. If not, then something's wrong, right?
Let's do it.
Yeah, okay. So
who wants to go first?
I'm still uploading mine.
Okay, anyone's done?
Whenever someone's done, we can start.
Ian is pretty fast usually. So Ian, how are you doing there?
Well, right now I just uploaded it, so because it wasn't working, so I refreshed it. Yeah, it's working.
So
it's not telling me the distance.
So when you're bringing your hand or any object closer, do you see the change in the numbers in the serial monitor?
No, it's around 140.
Okay.
Mine's around 0.
Check your wiring, make sure everything wires correctly.
Yeah.
Why? Go one by one.
It's not showing distance.
Wait, what do you press to measure the distance?
You don't press anything.
Yeah.
Serial
Once you
monitor.
upload
Working.
Oh, it worked.
It's not working.
It's the on the right, the button.
It's
in your
not
Arduino ID.
Okay, yeah, it's working.
Yeah. Okay.
Mine's not working.
Okay, so let's go through your wiring.
It's there.
Can you check them one by one? Where's ground connected? Where's volts connected?
Mine's
and
working.
Network?
Oh, 0.
Katerina's working, right?
Yeah, except is the serial monitor supposed to go so fast you can barely read the numbers?
Yeah.
Well, you can still see the numbers, and you can still see the numbers.
Yeah, it's kind of hard to read them though because it's going so fast. But yes, mine's working.
Good.
Okay, it's working now, I think.
Okay. So what was the issue? Was it wiring?
Mine's not working either.
Okay.
Yeah,
I forgot it all set up and everything.
Just checking the
code
wire.
is having some error.
Okay, those who are not, who can't make it work, Alex, can we take them to breakout rooms?
Sure.
I feel like we could probably just debug it here because that way other students who also may be having the same problems can see.
Actually, that's a good idea. But Will, can you show? But we need to see the Arduino, right? We need to see the set.
Yep.
So you literally have to go one by one through each wire.
I prefer to go to a breakout room, but
You prefer to go to breakout room. Okay.
Okay.
So Alex, can you send Will and team to breakout room?
Sure.
Yeah.
I'm having a bit of.
Okay, Ricardo, can you point the camera? We will try to help you here. Yeah, point the camera to your Arduino set. Like
Okay,
that.
Team and Will, you're welcome to go to breakout room and troubleshoot it.
Yeah. So I connected it like this.
Okay, Ricardo, I think your issue there is that your wires are in front of your sensors. You see, guys, how I connected them?
It would still work, rather. It would still work. It would maybe show some garbage numbers, but if the wires are between the sensors, as long as there's nothing infrared directly in front of them, that should work.
Yeah.
The only thing that I think Ricardo didn't really upload the sketch because his running light's still running. If he would have uploaded the sketch, running lights probably wouldn't work.
Right, that makes sense. So yeah, make sure you push the code, right, to your Arduino.
You upload the code, and when the code is uploaded, your Arduino should do nothing until you open up the serial monitor and start seeing the numbers.
Yeah, check your ports first.
So I have to delete the code for the light.
You have to take the code from the chat window, you have to paste it in the new Arduino project, and you need to push it.
Yeah, if you want to keep your lights, you can. Just create a new Arduino project.
Yeah, that's what I did.
Yeah,
okay.
Go the file new, and this way your running light project will remain intact. You wouldn't have to delete it.
Just you share your screen so we can see what you're doing.
Yeah, let's take a look.
Yeah.
What?
Are you sharing?
Oh, I can't share.
Oh.
Are you allowing, Alex? Yeah.
It's the default thing, advanced sharing, all participants. Go.
Okay, Kranti, how are you doing?
All right, here you go.
I uploaded it here, but it's having errors.
I'm uploading to the board. Let's see, where is the issue? Go to check the port. You're in the Zoom window right now. It's
no. Click on
menu. So select Arduino first.
Yeah. Click on the Arduino app first so that you can see the.
Yeah, now you go to tools.
Nothing would happen.
Yeah.
Select the one that has Arduino Uno. Yeah, this one.
Yeah, that's a very common mistake. So
and now try to load it.
Still having an error.
Problem uploading to board.
Resource busy. Okay.
Is it possible that he doesn't have any more memory on the board?
Shouldn't be. Okay, let's close all the windows that are not used.
Yeah, buddy, can I ask you to mute your mic, please? Yeah. Yeah. Thank you.
Okay, done uploading. So now if I'm to call serial monitor, you should have distance values running there. Here's your distance. Now try to put something in front of it, like your hand, and let's see if it affects it.
Oh, perfect.
Yeah, now it's going very low numbers. Now it's very high.
Yeah, so as you move your hand closer and farther away, you should see the distance changing, that it shows the distance to your hand. You see?
Yeah.
Excellent, so it means it works. So congrats, this is a sensor in action, and if you would like to add some logic to it, I will show you later how to do it. But at the moment, good job. So I'm just.
How's everyone else doing?
Okay. Ranti, how are you doing there, honey?
Grant is back.
Can you unmute your mic, please? Yeah.
Here, I'll just mute them.
Yeah. So can you share your screen? We want to see the number readings from your from your serial monitor.
That one. Not working.
Good job. And click on that magnifying glass on the right. Yeah, serial monitor.
Your distances
something's
are
wrong.
0, so something is not connected correctly.
So can you check the pins? Make sure that trigger and echo are connected indeed to pin 11 and 12.
And that there is a power in the correct way attached to the other 2 pins. So G and B connects to ground, and VCC connects to +5 volts. Make sure that they're power, because the digital sensors cannot operate without power. If you unplug the power, it's not going to work.
And trace all your way, right? So like in my case, for example, I connected to the power bus on the side, but then you have to make sure that that power bus actually connected to the power on your Arduino, right?
I don't know. I was taking the second one.
So here's my example. I have the red wire connected to the positive bus, and then I have another red wire from the positive bus that goes to the 5 volt, right?
Let's call this one.
And same thing with the ground. Yeah, just show it to us.
Oh. So right now,
Alex, did you capture what was wrong with her board?
No, I didn't see anything wrong.
Francie, can you show that again, please? Yeah, closer. There you go. Can you show us cables one by one? So where is the ground connected? So that's your ground. Where do you take that? Just literally show it, trace it with your finger.
Ground supposed to go to the
Is it going to negative bus?
to blue line, right?
Negative bus, right? On the side, yeah. And then do you have anything that takes the power from there and brings it over the gap to the row that connects to your pin?
Is everybody having problems, or are some people good?
Some people are good. Ricardo works, I know for sure. Ian.
Yeah, we're just troubleshooting right now.
Because the problem that me and Rylan had were the 2 wires connecting to the ground and the 5 volt were backwards.
The echo and trigger pin were reversed.
Yeah.
Okay. Tim, you're good at troubleshooting. You want to take Francie also to separate rooms? Alex, can you send
Yeah,
me?
sure. Send her to the breakout room. I can take a look there.
Yeah.
Okay, Kranti.
Mine works.
Assigned to breakout room number 1.
What was that?
There you go. Tim, you can go, and Kranti, you can also go. It will be easier.
Yeah. Okay, Ian, how are you doing? Dhruva?
Good.
Report back. Dhruva shows me thumb up. Good.
Camera off.
And Ian, did you have a question? I think you had a question, right?
Yeah. So, how do I connect the light to go on when it senses something?
You have to program it. Right?
You have to put if statement in it.
Also, how do you make it so that it tells you, it says distance in front of the numbers on the serial monitor?
I think it currently does say the distance.
But with mine, it just randomly shows nothing.
You want to share your screen?
It says 5. It just okay.
Share your screen. I will take a look at your code. If you pasted it and copied it correctly, it should say distance and number.
See right here, this one. It doesn't say distance.
Because it's not correct code there that you use.
Oh.
Where is this code came from?
From the I know how to copy and paste it from the Tinkercad. So I
So
copied
you
it.
copied this to Tinkercad?
Yeah.
From my sketch.
Yeah.
I not quite recognize it. Let me.
Refresh it before you do that. Yeah, I ran to that issue yesterday.
Is
It
it
might be
taking the sound waves? Like the boop, boop, like the sound waves?
Yeah.
What?
I think that's coming from Ian.
No, I
So
think
if
it's
we
coming
can-
from actually ultrasonic sensor and microphones picking it up.
Yeah, so I'm saying that one of the microphones is picking it up, but when we muted Ian last time, it generally went better.
But now we're troubleshooting him, so we can't mute him.
So yeah, so we're just
So
gonna
Ian,
wait.
Ian, you need to replace this code with a different code. The code that is in the chat is different. It has way more lines in the loop code.
I can hear it without the computer. I can hear this sound wave.
You can? Well, then maybe you
It
have
might
a
just
bad
be the
ears.
ultrasonic sensor.
Okay, I'm gonna mute myself.
Yeah, there we go.
How come my microphone doesn't pick up my sensor?
Is your sensor pointed at your microphone?
Not exactly. It's pointing at me.
Maybe his sensors.
It might be something his code is doing.
It might be something his microphone is doing.
Okay. I know that infrared, when you look at the remote with your bared eyes,
Phone?
Guys,
it doesn't show, but if you use your phone camera, you can see the blink of the infrared sensor.
it's 11 o'clock now.
Yeah, we can take a 5-minute break.
Yeah, if you guys want to like take a break quickly, and the ones who still needs help will help. And the second hour we are going to cover remote infrared remotes.
Are we gonna light up any LEDs if we bring the?
Oh yeah, that's simple. Let me actually quickly, while we on a break, I will attach my LED to pin number 10, and if the distances goes below a certain value, I'm going to.
Did it work?
Now it's showing just 0, distance 0.
Check your trigger and echo and make sure they're.
Yeah, make sure that you connect
to
it
that
properly.
same pin that you send the. Well, it shows something. So bring your hand closer. Anything changes?
Okay, I'm replugging it.
Oh, there you go.
There you are.
Yeah.
This is the screen, right? Okay, so it works.
Perfect. Yeah, he's got it set up. Cool.
Yeah.
Okay.
All right, so yeah, let's have students take a 5-minute break, and if yours doesn't work, stick around and we'll debug.
Yeah.
Alex?
Yeah.
I'm going to say that I might not be able to come tomorrow
Why?
because I'm going camping today right after.
Darn, I want to go camping too.
So maybe I'll connect if I get internet. If I can find somewhere with internet.
Yeah, otherwise we will just check the recording when you get back.
Yeah, pack your set with you if you have an internet, log in, and we'll be happy to see you. If not, just then after the camp, when you come back, check the last day recording and try to do the project, okay?
Yeah, okay.
Awesome.
So let me see if I run this code, what's gonna happen.
Now it's showing 0.
Shows the 0. What changed? Check the
Nothing.
wiring. Sometimes they're loose, maybe that's what it is.
Oh, okay.
Can I go to the washroom?
Okay, guys, for those who wanted to introduce the LED, and have a logic that the illuminating LED, if the object comes to a close proximity to the sensor, just add this if statement in the middle of the loop after distance is known. So once we figured out the distance, after that line, you can make some room and put the if statement. If distance is less than certain value, I put 30. You can put anything you want. So if you're doing a room burglar alarm, put it like 2 meters because you want to detect the intruder as far back as possible. If you want to protect your candy jar, then you can put it next to candy jar and make the distance smaller so that it wouldn't freak out when moms come to a room, but it start freaking out if somebody reaches out to the jar and starts stealing cookies. So you can put 30, 50, any distance in here. And if the distance is below 30, then you write to a pin that LED is connected to. I selected it to be 10 as a high. And if the distance is above 30, then we're going to keep it low. And in my situation, when I bring my hand close to the sensor, light comes up. So this is how you do it. And I will put it on the Tinkercad as well. There you go. Tinkercad now has the code with the LED connected to pin number 10.
Alex, can you please put the code on the chat?
In the chat as well, okay. There you go. Stuff between the two lines there, the latest. I kept the same code as we had before. Trigger and echo are 11 and 12. What the only difference is that I added if distance is less than 30 in the middle of the loop. If you wanna implement that function, please go ahead and do it.
It worked. My wires were backwards.
Okay, perfect. So now when you move your hand back and forth, it changes the distance on the screen. Excellent. Yeah, and if you want to turn it into a full intruder alarm system, then add a light. So guys, Amazon has a siren for home alarm system, or a thing like this, wireless home security door window burglar alarm. This one already kind of has a thing sensor, but you can just get a buzzer that is super obnoxiously loud and try to pair it with your Arduino. This guy, for example, it is powered by 12-volt DC. You may need to use the relay that is part of our Arduino kits to power it, because Arduino cannot put out 12 volts. It puts out 5 volts, but relay can make it happen. So you can convert it to 12 volt or any other voltage for that matter.
Alex?
Mm-hmm.
How do I put an if statement that goes like, if it is lower than 100,
yeah,
turn on one light, and if it's higher than 1,000, turn on 2 lights. How do I like that?
There is an else if statement. You can do several conditions. So you can do else if like this, and inside here you can put distances above 1,000. Right? And then have a standard else. So you can have more than one if in the same group. So you can select if distance is less than 30, then digital write pin 10 to a high. Then else if distance is above 1,000, then you create digital write to a different pin that creates lights up another one.
Yeah, and then, we can take advantage of our...
Yeah, and then you can do another else and 2 more brackets. And in that else, you just put your standard all LEDs off. Digital write 10 low, digital write 11. So imagine if you have, for example, pin 9 for the distances below 30, pin 10 for distances above 1,000, and then if none of those conditions are met, both 9 and 11 go to low. Something like this. Do you see the code on the screen?
Yeah.
Yeah, so that's the idea.
Can we start learning about remotes now?
Yeah, we can go to remotes.
Can you copy this to the chat, please, Alex, for those who wants to try?
I already put it in the chat. Yeah, it's in there.
Ooh.
For everybody else, I'll keep it simple here. Just one else. Oops. What did I do?
What do we do with the tab thing underneath?
Alex, can you please put the one with the second and 2 else's in the chat as well?
Well, I already kind of erased it.
Can you undo it?
How do you undo the undo?
The control that doesn't work here?
Control F?
Oh, you have undo buttons on the top. Does that help? No?
They're at the top there.
Yeah, they only work for the schematic, not for the code.
Oh.
That's fine. I'll go back to my program here. Copy it from here. Paste it here. There you go. Okay, guys. You'd like another couple minutes stay on this topic, or you want me to switch over to infrared?
Remotes.
Remotes. Excellent. All right. So I will save this thing so that we have it. I will call it Alex Sonic. And I will keep it for everybody who wants to go and borrow the sketch design and code in the future. And I'm gonna go back and I create different circuit for the
how will we be using the skip forward and the up and down and plus volume and the numbers? I don't get that.
Skip forward volume, what?
Like how are you supposed to use the remote? And like what are you supposed to be using it on?
That's exactly the topic of this hour. So listen up, and by the end of the hour, you're supposed to be fully comfortable with all those buttons there. Sound good?
Yes.
Alex, infrared, remote. All right. So let us start sketching. I'll bring my trusty breadboard and the Arduino. Infrared sensors are, I'll show you how it looks.
Oh, my photo sensors aren't working anymore.
What a sensor or ultrasonic sensor?
Infrared.
Yeah, I know, but like,
So guys, you're gonna be looking for this guy.
Okay.
In your boxes, please look for this guy. And
Got
then
it.
let me know if you found it.
Got it. The weird looking masked black thing.
Masked black thing, yeah. So that black thing is actually infrared receiver. So that little eye blob can see infrared illumination, which your eyeballs do not. But it will see the remote controls of any kinds that are in the house.
Is it this one?
I do not see you. Let me show. Can I see? You're not.
It's kind of creepy. Should I be watching us watch TV?
Yeah, that's the one. Yeah, that's the one. Ajwat, that's correct.
Yeah.
Yes, Kranti, this is it. Yes, Ian, this is it.
Which section is it in?
This guy has only 3 pins because we don't have echo anymore. We only actually have echo, so we don't have trigger anymore. It's always listening. Rather, this is joystick. Put it back.
Is this the right piece?
Yeah. So it was in the same compartment where the
right bottom one. Yeah.
Yeah, right bottom one where we actually found the photos.
If you
Wait, this one?
It was in the same compartment where a potentiometer was, guys.
No.
What's
Ayan,
the
this is
R
not
and the
it. This
Y?
one is a joystick. The one that you're looking for has one teeny tiny.
What's the R and the Y?
Very small, and it was in the same compartment where your potentiometer was, on the bottom right corner.
Alex, is this it?
Catherine, yes. This is
Yeah.
it.
The
I think Ayan's still looking.
What are the R and the Y for on it?
Okay.
This was literally always on my laptop.
So G is intuitively stands for ground.
It's this one, right?
The R would be the power,
Does
and
it have
the
this
Y
black,
would be
black
your
thing?
signal.
Like this?
Yes, that's it. You're rather
yeah.
correct.
No, I'm asking Ayan if he's the one he found has that feature in it.
Yeah, it does.
Yeah, then it's correct.
Okay, so everybody found it. I'm closing this window now. And in our Tinkercad, the infrared sensor is... Where is our infrared sensor?
Well, can we ask you to mute your mic? I love the song, but we can't hear Alex.
It's Rylan, not me.
Oh, okay. But it comes through your mic.
Okay, here's the infrared sensor. It doesn't look like the one that we have, but hopefully we can make sense out of it. And here's our remote. Oh, they even have a potato battery in here. Jeez. And a lemon battery and potato battery. Oh, how funny. Okay, guys, don't tinker with my tinker. I only allow tinkering with my tinker. Okay, I'm gonna put it in here. And we need our usual ground and plus 5-volt combination. Hey.
Okay,
William.
Will and Rylan.
Can put
This
it
is
back.
not fun anymore, okay? We won't finish.
Do you want to learn or you want to just waste time today?
It wasn't me.
Who did it?
Who did that? Was it Rylan?
No.
No?
Nope.
Okay.
Now the wires are gone.
Alex, I suggest you open the your own project so that they don't do that.
Yeah, but
and
how do
then
I share the code with them? Through the chat?
Through the chat, yeah.
It's okay. I'll try. I'll give them one more chance.
Yeah.
If you guys gonna be violating discipline, we're gonna discontinue this.
Alex, do we take apart the other contraption?
You can, yeah. I would recommend it. If you want to keep it, you're welcome to keep it. Like I have everything, even the photo sensor, still on my breadboard, so I can go back. The idea is by tomorrow we're going to consolidate it all into individual functions on your main project, so you can just call it by name. So if you want to measure distance, you just call measure, and it will measure. If you want to run running lights, you call it running lights, and it's going to do running lights for you. All from one main program.
Okay, I'll just keep it.
Yeah. If it kind of bothers you and you want a clean slate, then of course feel free to break it. But if it doesn't bother you, I would recommend keep it.
But will they have to assemble it back tomorrow?
No, they don't have to.
Oh, okay. Then I guess you guys can take it apart.
Okie dokie. So this guy is connected like this. Ground goes to ground as usual. Then R letter goes to plus, and the last letter, the last leg that has Y on it, is connected to the pin
Which way do you recommend putting it?
It doesn't matter. It's infrared, so it will detect the signal anyway. So you put it with the eye pointing up. That's the only way you can put it. And this way you can like press a button and it will detect the button presses. So let me just see which one I connected this guy to. The Y would be connected to pin 9. Sound good? I'll put it to pin 9. So I'm gonna go here, and I'm gonna make it magenta, purple.
The light's gonna go. Yeah.
Okay, so something like this. Make sure that if you're facing the other way around with the eyeball like facing out, the letters have to be different. So G will have to be on this side now. So ground will be connected to the negative. R pin connects to positive. Y pin connects to signal. This guy, for some reason as well, it has power, ground, and out in a different sequence. So I may have to actually rotate it. Like, no, doesn't want to rotate.
Why don't you keep your figures in your room and not in the junk box? My mic is on, Rafi. I can hear everything you say. Don't say anything unless it's related to this. Why don't you turn it off? Because I do not want to. So do you have the program set up yet? Like the code?
I have the code, yes. I didn't post it yet. I will post it in a second. Give me a second.
Oh, I don't need you to post it.
You'd like to see it?
Is it like, do you have it in this, no you don't.
No, I don't have it in Tinkercad yet, no. Let me do pin 10 would be my LED, and receiver pin would be, I'm plugging the receiver pin into pin 9.
Okay, so Alex, we have G, R, and Y, right? So G is the ground, right?
Yes, R is the power and Y is the signal.
R is the 5.5 volt, right?
Yes.
And Y is which pin?
Y is the signal. You can pin, I pinned it on my schematic to pin number 9. You feel free to use whichever one, but make sure in the program you correct it.
Too much flexibility because those who just copy paste the code, I want to make sure their pin is on the same. So I put that in the chat, guys.
Okay. Yeah. All right, and this, if you guys have never used it on your computer at any circumstances, now is a good time to learn how to attach libraries, because once you put it in the Arduino, it's going to start complaining that it doesn't know what you mean. What does infrared remote means? So let me put the code in here. I'll delete everything.
Yeah, copy.
I'll go to the code, to the text, and I will paste my code right into here. So this is how the code looks. And this is how the Arduino IDE with the code inside looks. So if I'm to push it to my Arduino, it will work fine because I tried it yesterday. And yesterday when I tried it, it didn't work fine. And the why it didn't work, because it was complaining that library for infrared remotes was not present. And library is that little thing on the first line of the sketch. You see that hashtag include? That hashtag include actually looks for a certain file on your computer that has all the explanation to the Arduino of how to read infrared signals from remote. Arduino by itself doesn't know how to do it. So we have to import that file. That file, I can guarantee on most of your computers is absent. If you run this code on your Arduino, it's not going to like it. So I will post this code in the chat right now for everybody to take. Yes.
I just wanted to go snooping in what there was to pick from, so I put in all, and I found the four-legged the four-legged sensor. I found the four-legged DJ thingy sensor, ultrasonic sensor. I found it four-legged.
Oh, you found four-legged in Tinkercad?
Yeah, it's in all.
This is lovely. Let me look for it. If I go to all, and I'm gonna go Sonic. Hey, there's a four-legged sensor. How stupid of me not to find it before. Excellent. Good job.
Thank you.
Now I know that we can actually use that guy. Terrific. Excellent. Perfect. Thank you for the tip. So guys, I have pasted the code that you will need for this sketch into the chat. Please load it up into your Arduino and let's try to test it. So if you run it and it's gonna complaining that it doesn't know what irremote.h is, we'll have to go through a routine of adding a library.
Yeah, Alex, mine's complaining.
Yours is complaining. Perfect. So that was expected. And everybody else's should be complaining too. Now, how do we add a library? Arduino, when you install the IDE, already has a bunch of libraries pre-installed with it. In our case, infrared remote is not one of them.
Mine didn't complain.
Wait. I haven't finished
uploaded
the tables. Wait.
So, Will, if your has already uploaded, that means that infrared library, for some miracle, exists on your computer. So that's excellent. And that means that you can probably already start working with it. So if I'm to run this program and it's done uploading, and I'm going to, let me just re-upload it. I re-uploaded it. If I'm to open up the serial monitor and start pressing on the infrared buttons, I'm gonna get some sort of hex codes popping up on my serial monitor corresponding to each unique button.
I didn't get this one. It's only doing distance, not the...
No. If it's still doing distance, that means that you haven't loaded to your Arduino the recent code. So you need to load the code with infrared remote to your Arduino. So close the other window if you have it still there of Arduino. Close it in. Open a new file. Copy the code from the chat window into the new Arduino, overwriting everything that currently is there.
I'm on yours, and I'm just doing it from there.
And you're saying that your serial monitor shows distance still?
Well, I just deleted that one.
Yeah.
So if you override old code with the new code, there should be no traces of that distance thing.
Well, does your code start with IR remote on the first line and hashtag?
Huh?
What is it?
Does your code looks like this? What I'm sharing right now.
Code and see if your code. If not, then
it doesn't.
From the chat. Yeah.
Doesn't look like this? Then go and replace it with the new code.
Yeah, the thing with Tinkercad, guys, when Alex does the changes, you have to click the refresh button to get the new changes in, right? So if you're still using the old without refreshing, then it will show you the old code. I think Ian ran to the same issue. Okay, so Alex, I think that for those who are a little behind, can you show once more how to import the library?
Okay, now the library time. What do we need to do? We need to go to, let me find this place. Sketch, include library, and then manage libraries. That's what we need to do. So for all of those that have just loaded this infrared program into your Arduino IDE and have an error coming up saying that doesn't know where the IR remote is, you need to go to Sketch, include library, manage libraries. Once you select that option, you will have that little window pop up. This is a library manager. It will allow you to look for the different libraries online by typing the name into that little window here. So what we need to do, we need to type IR remote. And the library manager will automatically go to the internet repository and look for the libraries that are available with this name. And the one that we need is this guy, IR remote by Sheriff, version 2.2.3. In my case, it is installed. In your case, it is not installed, and you need to click install button to add it. Very simple. Once it's added, you're good to go.
Wait. So what do I do first, and then I search?
I'll go to Sketch in your menu.
Go again. In your Arduino IDE, on top menu, you select Sketch. Then in the pop-up menu, you select Include Library. And in another pop-up menu, you select Manage Libraries.
I can't find the Sketch.
It's on the top menu of IDE.
Can you share your screen, Ricardo? Maybe.
Yeah, now it's here. Now.
Okay.
Which one do we go on to?
You Google the Include Library, Manage Libraries, and in the window, you start typing IR, capital, and then small letters, remote.
Yeah, I got a bunch like robot IR remote.
Yes, you look for IR remote by Sheriff version 2.2.3. Looks like this.
Oh, wait, so after I go into Include Library, it is?
That's it. Then you just can go back and push your code
Alex,
to
it's
Arduino.
IR by Sheriff, right?
Yes, yeah. Click install, and once it's installed, you can close that window, and you're done.
Wait, so Include Library, and then what?
Then in this window, you type IR remote.
No,
in the little box, in the little box on top, you put your cursor in there.
Ricardo, Alex, it's easier if he shares his screen. We'll walk him through, and everyone will actually pay attention. Ricardo, go ahead, share your screen.
So
go to Sketch.
I get in here. I go to Sketch. I go to Include Library.
Manage Libraries.
Manage Libraries, the very first item there.
On top. Yeah. Then you click in the top box, you click the cursor and start typing IR, and then all letters remote. Yeah, remote.
You see it came by Sheriff?
Yes, this one. By Sheriff. Click install.
Very
Installed.
easy, right? That's
and
it.
Now you click close and you're done.
Just close this window and push your code to
And now try to upload the code again. See, it's no longer complaining. Well, it's complaining now again for the thing. So go to tools and make sure the port is correct.
No, it is correct. I can see it from down here.
No, you have some USB modem again. So try to go to tools.
It's working.
Port.
No.
Oh yeah, it is correct.
It is the correct port.
Then maybe close the other windows that are Arduino. Close serial monitor. I think that's USB modem that makes the distance thing. You see on the left top?
Was all the numbers
close this window, yeah. Try now to in this one as well. And
yeah, save changes.
If you want to save changes to that one, that was this.
Save.
Yeah.
Yeah, save all.
And try to upload now.
Wait, yeah, I got it. Wait, I think it's a problem. I remember that these weren't wanting to paste itself, so I'll just.
Yeah, I think the last bracket is needs to be removed, right?
No. Bracket's supposed to be there. It's just replace the brackets, yeah, because sometimes when you copy stuff in the Mac, those brackets create stray things. Do the last one, the very last one that is red.
Yeah. Yes. That is red. It doesn't recognize the last bracket. Can you just delete it? And
I already did the delete redo thing.
Okay, then try now. Try to push it.
I'm just doing everything just in case. Come back.
I'm having trouble.
Okay, Ricardo has left. You back?
No, I'm just telling my dad. He's just taking out the trash.
So it says void setup and it says exit status 1 redefinition of void setup. And then
you probably have two setups. You didn't delete the one that was in the window. You copied the code without deleting that was previously there. So you can only have one setup function.
You can always select Control A, delete, and then Control V to paste, right? Control A to select everything that's there, delete, and then Control V to
Done
paste.
uploading. Okay, Ricardo, now open up serial monitor.
Mine works.
Now find the remote control in your kit. This guy looks like this.
Control in my hand.
Yeah. Did you pull out the tab on the bottom? That little transparent
I
tab?
pulled it out before the classes started.
Okay. Now point your infrared remote to that thing and press the buttons. Nothing happens?
Random combat
Alex.
letters and stuff are coming up on my screen.
Alex, the code works because mine works.
Make sure to pull that thing off, right?
Excellent. So for Ricardo, your thing doesn't show any code. So I'm assuming that your power and signal wires are not properly connected. Make sure that the R cable goes to plus.
Can you show it to me? Because I couldn't correctly finish seeing the whole thing. Show it,
what do the different buttons mean? It's just random code.
Exactly.
Like,
So let me show you something here.
Because I get FFFFF for any random button.
Yeah, and now that you know which button produces which FFF, you can use that FFF to code that button, right?
So let me explain you guys one thing. So once you have your code and it's running, let me close that serial monitor, open it again so it's clear. So if I'm to, for example, attach the action of my Arduino to the button number 1 on the remote control, I press the button number 1 and I get to notice the code, FF30CF. We take this guy here, we copy it, and we paste it into our if statements. So if result value equals to 0 multiplied by FF30CF, that's the code that we'll attach to button number 1. Then make your digital pin high and your LED is gonna blink. I have just attached an action inside Arduino to the button number 1. If you want to have several different functions attached to several different buttons, you're going to have to repeat the if statement, and you can create each statement to a different button. So if I'm to reprogram my remote from button number 1 to button number 0, I need to press button 0. I detect the code. Please ignore the FFFs. Only remember the one that has numbers in it. So 0 button has unique code FF6897. I copy this guy, and I'm gonna put it in here.
It won't let me copy it though.
FF6897. And now if I program my Arduino, my LED is gonna light up when I'm pressing button 0.
Oh, that makes more sense.
Makes sense?
So Alex, say I make one for every single button. I press one, and it would give a different LED to blink, right?
Perfect, yes, exactly. So you can use if statements through your code. So every time there is some sort of disturbance on your infrared sensor, that value, hex value, going to be remembered in the variable. It's going to be a results value, that guy. This guy going to assume the code that you have just intercepted. You don't even have to use the same infrared remote. You can use your TV remote from your actual TV. You can use any infrared remote in the house and decode each button because it's going to be sharing the same interface. Okay?
Why does it have a light at the end?
I figured out what was wrong.
Yeah, your remote, when you press on it, let me see if I can actually detect it. You see, if I'm pressing that remote button, you see that blinkage? that happens on the tip of the remote. That's the infrared signal that that LED is emitting right now. My eyes cannot see it, but the camera can.
Guys, can you all check your remote controls and see if you actually see
Also,
this?
guys, please note that your remote controls comes out of the box with a little protective tab attached to the battery here on the bottom. You need to pull it out, otherwise it's not going to work.
I did pull it out, but
yeah, that little tab in there is just to keeping the battery from depleting while they storing it in the factory.
Include a remote.
Guys, the interesting fact, like I don't see the light with my naked eye, but if I point it to the computer camera, then I see it's emitting something.
Yeah, exactly.
I don't see it with my naked eye, yeah.
Para que todo el mundo lo pueda utilizar, contribuyen sus funciones.
Your phone camera also works to do that. Okay.
Exactly. If you look at the remote through your phone camera, you can see it blinking as well.
Le hicimos download al remote control.
Entonces, eso lo hizo no tal cual el inventor Arduino, pero alguien que
Okay, we have about 20 minutes left, and don't worry, guys, if we will stay here until it works, okay?
Alex, can I disassemble?
Are you done the infrared thing? Does it work?
Yeah, mine works.
So did you attach LED to it, and your LED also blinks when you connect it to a button?
Nope.
Yeah,
This is something you would like to do.
We want to control the button. We want to press the...
We want to control LED with the remote. So every time you press the button 0, your remote's supposed to come off. Sorry, actually, I'm having the conflict here. Pin 8 is my LED. So guys, the program is very simple here. We assigning your receiver pin to pin number 9. If you would like to modify, if your pin number 9 is busy, for example, with something else, and you have pin number 12 available, you can just reassign it right here in the program. Instead of 9, put pin 12, and you're gonna get your infrared on whatever pin your Arduino is having free right now. On the setup function, I'm setting up my serial monitor. I'm enabling receiver, infrared receiver, and I'm setting up pin 8 as an output. That's for my LED. This is for LED that I want to light up using my remote. Okay? And inside here, you don't have to memorize any of that. IR receive, decode, blah, blah, blah. All those keywords actually have been pre-programmed inside the IR remote library. So if you remove that thing, Arduino start complaining that I don't understand what is this IR receive decode means. As soon as library is there, library tells Arduino IDE what all those things are, and it works correctly because other engineers done the job for you. They went ahead and they pre-programmed all those services for you that can detect the infrared signals and decode the hex values. So serial print, we already know that command. It just basically throws out to the serial monitor whatever we just detected on our infrared receiver. And then we make our logic, which would be if the button is pressed and that's the button that we want, then we do the action. In my case, it lights up LED for a second and then it turns it back off.
Make sure your LED connected to pin 8 if you're using Alex's code, or just change that 8 to the pin that you're using, right?
Yeah, if you, for example, would like to use this as the light switch in your home, with the, for example, button 1 will turn the lights on and button 2 will turn the lights off, then we're gonna have to do it in this way. We're gonna have to put it like that. We're gonna turn the lights on, and then we're gonna have a different if, and we're going to put it in here like that, and that will be turning light off. And I want to see what button 2 is doing. Button 2
Alex,
is doing this.
I tried that and it's not working. Just won't get the same code.
We're gonna look at it.
Okay, Tim, do you want to take Will to a separate breakout room? Alex, can you create a room? We have only 15 minutes left, so this is a time when we have to go through everyone.
Yeah, Will is already a member of breakout room, so he can go there anytime. Tim and Will, if you'd like to go and troubleshoot your schematic, you're welcome to join the breakout room and try that. And in my case, I will load this program. I will see if I can turn my lights with one button and turn it off with the other.
Okay, Tim, Will's gone, so you can go to that same room.
So I'm turning it on and I'm turning it off. So right now with the button 0, when I press it, my LED comes on. And if I press button 2, my LED comes off. So I have like on and off switch, completely remote.
Nice, okay.
Which is super cool. And you can start thinking about cool ideas that you can do now with this kind of knowledge. This is very dangerous knowledge, making you very dangerous people. Because now you can infrared control people, or infrared control electronic devices anywhere.
Yeah. Okay, guys, let's go through and make sure you guys are doing this correct. Okay. So Ian, how are you doing there?
Oh, the TV from anywhere.
Right now I'm trying to put the code in that you have. Which is
already on the next step. So the first one worked?
Using what?
Yeah.
Okay, perfect. Ricardo, how are you doing?
The light isn't going on because.
Yeah. Okay. I think I think you know what you're doing. So if you run into trouble, let us know. Okay. We'll move on. Ricardo, can you unmute your mic and tell us how you're doing?
Oh, I got it all good. I can use the remote to turn on lights.
Good job. Nice. Nice. Excellent. So if you want to do a little more challenging job to
Catherine says her works as well, so that's good. So I'm posting another code with one button turning the light on and another button turning it light off.
So that's a challenge if you want to actually create 2 buttons. One will turn it on and the other one will turn it off. Right now, your infrared turns on, then there's a delay, and then it turns off automatically, right? So that's how it's supposed to work.
Guys, once you have the good grip on this thing, you're gonna want to add more LEDs. For example, you pressing button 1 and yellow LED comes on, but if you press button 2, your green LED comes on.
Yeah,
and then if you press button 5, all LEDs like come on and off like a couple of times or start blinking. So tomorrow we're gonna consolidate all that things into different functions, and we're gonna create effects. So that'll be
just as a challenge for the homework, just add maybe 2 more LEDs and assign different buttons to turn them on and maybe automatically off, right? Just do something fun. Yeah. Just for the presentations tomorrow. And Ayan, how are you doing? Unmute your mic. I'm just walking one by one through everyone, making sure it works.
Ayan has moved to Australia. He's upside down.
So yours one works, right, Ayan?
Yes.
Good job. Awesome. Yeah. Kranti, how are you doing? Oh, okay. Awesome. Good job. And Katya, you said yours one is okay, right?
She reported that it worked.
Yeah, I can have it blink a light.
You guys are so smart.
Yeah.
Yeah, actually, in our FLL, in competitive one, we always very often use Arduino to back up our projects, right? So as you know, the FLL, we have the robotics component and the project. So yeah, it's amazing. Like this year they built the house out of Lego, and the project was about the stellars that would lift the house up in case of flooding, right? So, and they actually demonstrated it using the Arduino, so that was pretty cool. Yeah. The other, they did the sensor that followed the light and heated the, provided the heat to entire community, and they just created a model and also powered it with Arduino. So it's pretty powerful tool, and it's very handy to know, and you guys just have to turn on your imagination and creativity and use it. Yeah, so go around your house, maybe do the add the sensor to your door so that whenever someone opens the door, it provides some signal so you know who comes to you to your room, right? Okay, so just as an idea.
I have a dog alarm. I do not need a door alarm.
Okay, yeah, just throwing some ideas there. Okay, Ajwat, I'm sure you're doing fine there, right?
Yep.
Awesome. Dhruva, can you report? You're muted, buddy. Dhruva, can you please unmute your mic and let us know how you're doing?
That works.
Can you ask the question again?
No, I'm asking Dhruva. No,
Oh.
that's not you. Yeah, I want to see if how Dhruva is doing, but I guess something's wrong with his mic because we can't hear him. Okay, Rylan. Rylan, how are you doing? Can you unmute your mic? We can't hear you. Okay, so Dhruva and Rylan, we can hear back from them. Hopefully they're still with us. Other than that, this is success. You guys managed to do this really well. So again, for the homework, please add 2 more LEDs, or 2 or 3, up to you guys, right? And program them to turn them on using different buttons, okay? Program your infrared remote to turn those LEDs using different buttons. So if you want to add something else to that, that would be cool. Just use all the knowledge that you learned. Alex, we still have 10 minutes. So
8.
Looks like this was easy for them, yeah. But we couldn't hear back from Dhruva and Rylan. Okay, and again, guys, these videos will be shared on our channel, so your parents actually see if you're there and how you're doing your work. So you don't want to just switch off your camera and go watch some cartoons, because your parents will know, right?
So guys, any questions on today's? Any questions on sonic sensors or infrared sensors?
I'm good.
Okay, can you add one more complication maybe? For those of you who reported that you were good, guys, did you try adding the second level of complexity that Alex introduced, when one button turns it on and the other one turns it off?
Actually, I started assembling, but then I want to start doing a little more complicated, so now I'm assembling again.
Awesome. Yeah, absolutely. That's the spirit we're looking for. Kranti, did you try that? The code on the screen right now? No? Okay. Well, we still have 10 minutes. Do you want to go ahead and try it? And if you run into issues, we can actually help, right? All you need to do is just add another line of code, right? What you see on the screen, line 19 to 22. He just added another if statement that will turn it off. Yeah. And this time, maybe guys, if you guys are pro now and can actually move faster, try to actually type the code. It's always fun. The way if statement works, it's if, then in curly brackets, you put the condition. What do you want to happen so that if statement kicks in? Then in figure brackets, you actually put the action, what you want to happen if that condition is true. That's pretty much the if statement, right?
Is it normal to sometimes accidentally chip a wire?
Chip a wire? What do you mean by that?
I mean, like, pull the black thing a little bit off the...
Right. Yeah, when I pull the wire, I try to pull it by the black thing. You know, that's the main rule when you try to pull the wire off the socket.
Yeah, that's what I did. But like the black thing, I did that. Like, I was pulling it and then the black thing slid off.
Yeah, so just throw the wire away. You have a bunch of wires. You have enough.
I know. I was just asking if it's like normal or something, or if that's what you...
Yeah, I just threw that away. Yeah, you don't want to, if you have any naked wires especially, you don't want to use that. Yeah, it's not safe, but I mean, the voltage is so low on this one, right? So we're not working with anything dangerous anyway. But the good habit is if you have any naked wires or broken wires, just throw them away. To be on a safe side. Okay, so it's 11:56. So Rylan and Druver, if you guys are back, so can you unmute your mics because we didn't hear back from you? Druver, are you here? You're muted and we didn't.
Yes,
yeah,
I'm here.
Yeah, we were going through the project through one by one and we couldn't get you to answer. Can you please let us know how you're doing and maybe turn on your camera and show
My camera
your...
doesn't work now. I don't see the button.
Oh, okay. But did you manage to do your project?
Yeah.
Do you have any issues? Do you need any help?
No, I'm fine. Thank you.
Okay, it would be nice if you could actually turn on your camera and show, but I guess if it doesn't work, it doesn't work.
I'll try to fix it.
Yeah, I just want to make sure that you guys know again that we're recording these sessions and your parents will have an opportunity to view, right? To actually watch this and see how you've been doing in this class. So just saying, okay? So yeah, Dhruva, so if you manage to do that, the homework for tomorrow is to add 2 or 3 more LED lights and assign different buttons to turn them on, okay?
Okay.
So you just need to figure out how to repeat that if statement and assign it to different pins to turn them on and off, okay?
Okay.
Yeah. Okay, so on this note, if you guys don't have any questions, do you have any questions?
Yes. So right now mine is not working. Okay. So I've programmed it so that 1 and 2 work. But right now the serial thing is not working. It's only picking up for 1.
Go ahead and share your screen.
I will stop sharing. You can share yours if you want.
It's yeah, okay. So I'll share my screen. Screen share. So right here.
My Wi-Fi is really unstable right now.
We're almost done, Ayan, so it's just 2 minutes left. If you're good,
Ian, you have removed the print function in the inside your main loop. So you replaced with if, so you obtain the results, but your serial print command is missing now. So I would suggest
this
add
part?
that back. Yeah, so go back to my Tinkercad.
Okay.
No, actually, wait. You actually printing it. Serial printing results. Yeah, you do. So yeah, when you press buttons, you should have those things coming up in serial monitor.
But they changed all of a sudden.
No, they cannot change. If you press the same button, it's supposed to be always the same.
But it's not. I reprogrammed it so that this one's 1 and this one's 2.
Okay, now press button 1 on the remote. So it says 0152. Yeah, you need to replace that. Why it's showing FBAC0? It's not supposed to be that. Can you close the serial monitor and open it again?
Okay. Wait, maybe I should upload it again.
Yeah, re-upload it just in case.
Okay, now I'm gonna press 1.
No, wait, it's done. Now do.
So that's a code for your 1, right? Make sure
1, 2, 3, 4,
copy
5,
paste
6.
that into your code.
No, the code is different. It's the different number of numbers.
Yeah, but that's what I mean, right? Maybe he pressed the different buttons. Just make sure whatever right now your remote control is showing that number, just put that number in the code for 1.
Okay, but this is number 2. It doesn't even work. Number 2 doesn't even work.
Oh, so you're pressing number 2 and it isn't working?
It doesn't react?
Oh.
Yeah, it's not react. It only reacts if I press 1 like 100 times.
How about other buttons?
0.
Try to pointing it remote into the infrared.
There you go. Yeah, so maybe there was no connection. This light has to point to your device, right? To your infrared chip.
I'm pressing 2 right now. It's not working.
Okay, for everyone else, guys, it's 12:01. Thank you so much for being with us today. And
I have a problem.
yeah, if you're here tomorrow, we will see you tomorrow. If not, if you still have a problem and need help, stay online and we'll help. We'll stay here. Otherwise, you can sign off. Okay?
Let's
Bye.
remove that delay.
Alex,
Delay maybe missing.
bye. And Alex, you can stop recording.